Good morning, everyone. Myself Gautam Sharma, and I welcome you all in a Sapience Education. And for further more details of our institution, you can visit our website www.sapienceeducation.com. And if you want more and more courses and different varieties of courses, also you will get all the details in our personal app, and the link is given below. There you can also download our app. So today I want to discuss about the circular motion, which is a part of a motion. I will discuss how circular motion happens and what are the forces acting on the circular motion, and I will also discuss about the application of a circular motion. Okay, I hope you will enjoy this session. So let us consider what are the circular motion. Okay, so let us consider an object is being rotated by the string. So what will happen? See here, it is your circular motion. See, there is a string and there is an object. Okay, an object is being rotated with the help of a force is being applied at the center, and this object will rotate every time in a circular motion. Okay, so as you know that circular motion is a uniformly either it is uniform or non-uniform. It is accelerated motion. It is accelerated motion. Why? Because direction is every time changing, and we know that for any type of acceleration, as per the second law and first law, we know that for any acceleration we require an external force. We require an external force. Okay, like this. We have already discussed this thing. F net is equal to mass into acceleration. So acceleration, for if acceleration is there, so net external force will be there. So it is not possible for any circular motion that it will happen without any type of force. So there is always a force, and which is acting toward the center. See here, this object is try to go upward direction, so central force try to make it bend and it remain in this path. See, every time central force will be acting toward the center, and this is called centripetal force. The force acting toward the center is called force acting toward the center is called centripetal force. Okay, I hope you have understood now. Okay, now see, in the figure you can see that if object is or car is moving in a straight path, so what happen? Only two type of forces being acted, that is your mg downward direction and reaction force in upward direction. But when it tries to move in a circular path, see second figure, it is your circular track. Okay, it is your circular track, and if it move in a circular track, what happens? See here, if a car is moving in a circular track, so a car is moving basically in a circular track, so what will happen? So you know that there will be a normal reaction force, mg will be downward direction. There will be an extra force which is called centripetal force. Why centripetal? Because we know that for any circular motion there is a need of an external force, and this is known as centripetal force. So I will discuss more about the centripetal force here. So basically, if you want to define circular motion, so by reading this you will able to understand what is circular motion. See here, we know that an acceleration of a body moving in a circle of a radius r with the uniform speed is v square by r. So in any circular motion, so acceleration will be v square by r directed toward the center. For example, a stone is rotated up in the circle by a string. The centripetal force is provided by the tension of the string. So suppose this is your object is moving in a circular path, so there is an string, so tension will act toward the center. Okay, centripetal force for motion on a planet around the sun is the gravitational force. See here, if there is a sun and there is a earth is being rotated around the sun, so definitely some force is there which will always act toward the center to make this happen, to make the earth in a rotation revolution. Okay, to make the earth to revolve around the sun, there is a need of force, and that type of force is called gravitational force, and this gravitational force act as a centripetal force. Okay. Now for a car taking in a circular turn or horizontal road, centripetal force is the force in the force of friction. See, very important. As we know that when car is moving here, if car is moving here, so what will happen? There will is a need of a centripetal force. Okay. So which type of force is acting in this turning of the car? So can you find? So no strings are there, so there will be something. So only one thing is there when while you are turning while you are turning in a circular track with the car. So only one force is acting here, and that is your friction force. Friction force between tire and a surface. Tire and surface. Okay, understood now? So this friction force is act as a centripetal force. This friction force act as a centripetal force. Okay. Now specifically, I will use the formula how to detect this. See here. This is your turning on a circular track. Okay. So this is just turning on a circular track. So from figure I can show you. When a see here vehicle takes a turns on a circular path, it requires centripetal force, and the type of gate tendency to skid outward. Otherwise, if no friction force will be there, so it will skid outward, and you won't able to do a circular path. You won't, or car won't able to follow the circular path. So the vehicle can move in a circular path safely. We only require the force which act as a centripetal force is a frictional force only. Now for safe turn, friction force should be greater than what? Friction force should be greater than the required centripetal force. If friction force will be less, then what will happen? Car will move outward or car will skid. Okay. So avoid this. Friction force must be greater than the required centripetal force. Now as you know that this is a car is moving, so weight of the car acting downward is mg and reaction force is n. Okay. Now tell me, car is moving toward the center, so friction force will be F, and since it is being accelerated towards center, so there is a need of a pseudo force, and this pseudo force is known as mv square by r, and that is your centripetal force. Okay. So from this equation we can we can solve this, that n minus mg is equal to 0, or reaction force is mg. As we know that friction force is mu into n, so that is mu into mg. Okay. Now when I will talk about the horizontal axis, so what are the equations guiding here? So in horizontal axis, what are the equation here? In horizontal axis we can say that frictional force F is equal to mv square by r. So since frictions for safe journey friction force should be F must be greater than required centripetal force, that is mv square by r. Okay. So friction force has a value of mu mg must be greater than mv square by r, and mm got cancelled out. So we can say here mu r g is greater than b square, or we can get b is less than root under mu r into g. So from here you can calculate the safe velocity. If I will increase So suppose I have got say velocity 30 km per hour. If I will increase from 30 to 50 kilometer per hour, so definitely our car will skid. Okay, so I hope you all have understood this. Now I will talk about the banking concept. What is banking concept? Banking of a road. Banking of road. What happens, see, we don't only depends upon the friction force of the road, so we try to make a road such a way that if in spite of being more speed also we can turn it safely or we can round off safely. So what we will do, we will do banking means what, we will increase the height of one side. See, if my car is moving like this, so height of this path or this radial path should be increased one side by h, you can say. Okay, so this is the method of a banking of the road. This is the method of the banking of the road. Okay, so from figure I can you can understand why banking is done. See here, so that it won't move outward, that will be car will not skid. Okay, car will not skid, and if car will not skid, then we can say that it is safe. So see here, basically we will do discuss here about a banking of road. Now in case of banking of road, we will ignore friction. Ignore friction. If we don't want to take a friction into account, we only make the banking concept, banking of the road, and we will not consider any type of friction. Okay, and but we try to make the traveling or make the journey or make the vehicle motion safe. So let us consider there is a banking of road is done like this. See, this is a banking of road. Okay, now this is an angle theta, and this is a car. This is a car like this. Okay, this is a car. Okay, now okay, this is a car. So tell me, what type of force will act downward? So definitely downward will be mg. Okay, let us consider a reaction force. So reaction force will be always perpendicular to the surface. So this is a reaction normal force. Now I want to make or distribute into two component, that is, this is the angle theta. See here, this, if this is theta, so definitely this will be theta, and this will be 90 minus theta. So can I write here the component of n is here n cos theta, and component of here is n sin theta. Okay, so since acceleration is toward the center, this, so there will be a centripetal force acting just opposite of the acceleration. So that will be we can add a pseudo force here, that is mv square by r, mv square by r. Now what are the other forces are there? We have already ignored here friction. I am not taking here any type of friction, so I won't discuss about the friction. Okay, so if I won't discuss about the friction, so what are the equation we will get? Tell me. So can we write here n cos theta equal to mg, and n sin theta is equal to mv square by r. So this is a equation 1 and this is equation 2. So divide equation 1 by 2. Divide equation 1 by 2. If I will divide equation 1 by 2, so what will be the result? See here, n sin theta divided by n cos theta, this is equal to mv square by r divided by mg. So m got cancelled. So n got cancel, so it will become tan theta, and it is your b square by rg. So if we equate both, so what will happen? B square equal to rg tan theta. B square is equal to rg tan theta. So v can be written as root under rg tan theta. Rg tan theta. So basically, if you want to increase the velocity, see here, we need safe. We need safe traveling, safe speed. So if you want to increase the velocity, but if you want to increase the velocity and you want to increase the velocity but without increasing the friction, so we can increase the velocity by increasing the angle theta. So velocity can be increased by increasing radius of the track, increasing radius of the track. See here, if it is your small radius, now you make a large radius track, so velocity can be increased. Secondly, if you don't have a space, so you do the banking, that is the angle of the banking should be of the circular track should be increased. Suppose this is your base track, but I have increased it into theta, up to theta. So increase angle of banking. So in this way we can increase the velocity of the safe journey. So if I have increased the banking, so if I have increased the slope of the road, that is banking, I have done the banking, then we can increase the velocity and we won't able to, or car won't able to escape. So this is the very safe journey. For safe journey, use this concept. Okay, so I hope you all have understood this. Now another concept is, I will take I will use the friction force. So what will happen? See, in this figure you will able to understand that I am considering here a friction. Okay, so in this, if we will consider a friction, okay, if we will consider a friction, so let us consider a friction. So taking friction into account, so there will be two cases. Case 1, velocity of vehicle is very high. If very high, then what will happen? So it will try to go skid, so friction force will act downward. See here, if velocity will be very high, see, try to understand the concept. So this is the banking. Okay, in spite of banking, if I want to increase the velocity, so what will happen? So this car will try to go upside, so friction force will act downward. Okay, see here, this car will go up outside, that is it will try to skid, but the friction force will act in downward direction. This is your friction force. Now what type of forces are acting? So at first one force, that is your mg, is acting downward here. So can I write here mg? Now normal reaction force is acting here, and so can I split this component n? Suppose this is your theta, so this will be n cos theta, and in this horizontal direction it will be n sin theta. Okay, now I will talk about friction. So if friction is acting, suppose friction is acting here in downward direction, so friction has two component. See here, it is your theta, so this will be f cos theta, and this is your f sine theta. Okay, so basically if we combine, see, friction force, all are friction force, reaction force, all are acting on the same object, that is in a car. So I will draw the I will draw the I will draw this I will draw the free body diagram. So what we will get, see here, n cos theta upward, mg downward, f sin theta will be downward, f cos theta will be horizontal, and sin theta will be horizontal in this direction, mv square by r. So I can write here maximum velocity, v is your maximum, we are taking into account for maximum velocity, maximum velocity. Okay, I hope you have all understood now. Now we need to try to equate the equation. So how many equations we are getting? See here, I am getting an equation in vertical case, vertical direction, so this will be your n cos theta, it is positive, below it is your minus mg minus f sin theta. Now so we have got n cos theta equal to mg plus f sin theta. Now friction force is always written as mu into normal reaction force. So can we put the value here? So this will be mg plus mu into n sin theta, and this is equal to n cos theta. So this is the equation 1 which we have got, this equation 1. Okay, now we will talk about vertical direction. So horizontal direction. So horizontal direction, what are the horizontal direction we can also call as fx equal to 0. So what are the forces acting on horizontal direction? See here, this will be f cos theta plus n sin theta equal to m v square by r. So this is your maximum velocity. So put the value here, put the values here. In case of friction force, it will be mu into n cos theta plus n sin theta, and this is equal to mv maximum square by r. Okay, so we have got two equation. Now we need to solve these two equations. So what will be the final result? Let us see what will be the final result. Okay, how you will solve this? Now this is equation 2, and can we write this equation 1 as mg equal to n ng is equal to n cos theta minus mu n sin theta. Okay. Now see here, divide this equation 2 by 1. So what we will get? See, let us divide this. Okay, Now can I write m v square v max square divided by r divided by mg, and this is equal to n. Can I take common? So this will be cos theta minus mu sin theta divided by here also, in this equation also, we can take the common n. So if I will take a common n, so it will be mu cos theta plus sin theta. So n got cancel, m got cancel. So finally we are having v max square by r g is equal to, okay, one thing more we need to do is that divide it by cos theta. So both up and down. So divide it by cos theta, divide this equation by cos theta. So what we will get? 1 minus mu tan theta by mu plus tan theta. Okay, so basically we will get v maximum square is equal to rg into 1 minus mu tan theta divided by mu plus tan theta. So v max will be equal to 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 what I can write here? V maximum. So this is mu. Okay, so v maximum is equal to root under rg 1 minus mu tan theta by mu plus tan theta. So this is the case. So when velocity is very large, so you will get this formula. Now I will talk about the same thing, but velocity is minimum. So velocity is very less. So what will be the what will happen if velocity is very less? So velocity is very less. What will happen? See, it happens in some time. What happens? This is the banking, okay, and this is a banking, okay, and this is a car, okay. And if velocity is very less, so what will happen? So car will try to slide down due to its angle of inclination. So if it will try to slide down, what will happen? So friction force will act out upward, okay. So this is the tendency. So all thing will be remain same. See here, mg will act downward, mg will act downward, and normal force will be here, normal force will be here, and this will be a normal reaction force, and this is your angle theta. So this will be n cos theta, and in this direction it will be n sin theta. Okay, so suppose this is your friction force F. So F will have two component in this direction, see here, and in upward direction. Okay, so in this direction it will be F, this is your angle theta, so this will be F cos theta, and this is your F sin theta. Okay, so can we equate this? Now use for in horizontal. See here one thing more is that velocity we will use is a minimum velocity. Okay, velocity we will use here as a minimum velocity. See, velocity will be minimum, so mv square will act in this direction, so mv square by r, but it is in a v minimum. Okay, so if I will solve the equation. So first equation is in vertical direction, so in vertical direction, so n cos theta plus frictional force sin theta is equal to mg. So put the value n cos theta plus mu into n sin theta equal to mg, equal to mg. Okay, equal to mg. Okay, so here I have written mg, here also it is your mg. So this is equation 1. So I will talk about vertical horizontal direction. So take into the account of all the forces in a horizontal direction. So this will be what? N sin theta minus F cos theta is equal to m v minimum square by r. So put the value n sin theta minus mu n cos theta, and this is equal to m v minimum whole square by r. Okay, now divide equation 2 by 1, divide equation 2 by 1, divide equation 2 by 1, we will get n. For in equation 1 we can take n as a common, so we will get cos theta minus mu sin theta divided by, here we can also take n common, so this will be sin theta minus mu cos theta, and this will be equal to mg divided by, mg divided by, no, we can take see why mg, we should take this, no, we should take this at first, because this divide equation 2 by 1, right? So we should take this value, then downward value. Okay, so it should be like this. So it should be erase this. Okay, stock eraser. So divide equation 2 by 1. Okay, so okay, let's take equation 2 at first. So this equation I have to take first. So take n common, so this will be sin theta minus mu cos theta divided by, this part of this equation we have to take n cos theta plus mu sin theta, and this is equal to, this I have to take first, mv minimum square divided by r divided by mg. Got cancel, so it will be v minimum square by rg. Now can we divide, see here, can we cut this n and divide it by cos theta, divide this equation by cos theta. So if I will divide this both the above equation by cos theta, so I will get tan theta minus mu divided by 1 plus mu tan theta, and this is equal to v minimum whole square by rg. Now v minimum is equal to what? V minimum is equal to root under rg tan theta minus mu divided by 1 plus mu tan theta. So this is the minimum value of a velocity up to which car will move safely. Otherwise what will happen? Car will try to come down. See, in above case car will skid, but here we can see that car will come down if velocity will be less than the that velocity calculated value, so car will start coming down. So I hope you all have got the varieties of a thing, so that you can able to understand and For any type of query, you can contact us, and you can also comment in the comment section below. Thank you everyone. Hope we have enjoyed the classes. So I will meet with the numerical in a different section. Okay, thank you.